Well, thank you, everyone, for being here. This is our third day of the conference, ATI conference, the second day in which we are here all together. Um, so I would like to now introduce our first speaker of the day, Matthieu Pedergnana. He's an assistant professor at our faculty in Yashar University. He holds a master's degree in architecture from Sustainable Architecture Department in France, Lyon, and a doctoral degree from METU in Turkey, where he researched earth plaster. His work as lecturer and researcher focuses on natural materials for building construction. So we're very, very happy to have you here, Matthieu, presenting your research to all of us. Please be welcome.
Hello, everyone. So I'm really happy to be here today, and I'm really happy to show some of the work I have been doing since years, mostly with people like you, students or architects. And so sharing it in this conference is a very good opportunity, especially after the presentation we had yesterday and very enlightening presentation by our two chairs of yesterday, that let me think about the education process in architecture that we are going through here and show that there's always room for improvements, transformation, making something alternatives that can help students to understand better, not what is architecture, but at least how to think about their profession or their work. So what I will present today is just coming back from something that is deeply and rooted in me, is that I don't consider myself as an architect. I'm a builder. I studied architecture because I had to study something. I wanted to be a carpenter, not an architect. And I'm happy to be an architect. I mean, I'm happy of what I studied. It was just amazing. I learned a lot, but I didn't study only architecture. I studied how to build. And in the world we are today, building means being careful about what we build. And you will understand through the beginning of the slideshow why it is called heavy, weak, and dirty. Why I choose this title is because what you see in front of you here, in front of me, this is what I'm usually working with, and these are the comments of the people on what I am working on. So I just passed all those comments. I paste all those comments here, and yes, maybe those materials are like this, but the architecture, the buildings that we can do out of it are not this. So first, I will go very fast on it about biogenic materials. I mean, this is probably a word that you have not heard. It's kind of a new word, at least for architecture. Biogenic, you can translate it into natural, basically. Biogenic materials are materials that are coming from the nature, that are grown. In biogenic, there is biology, that's life. Okay, so the materials that are grown, but in general, we also add all geological materials that are not processed or reused material into this type of definition. And why biogenic material? But because those materials are grown. So if it is grown, as every life, it means it is storing carbon. It is made out of carbon. And if those materials just decompose, are getting burned, or so on, their carbon is just released in the atmosphere. So the loop is 0. And actually, they are even emitting atmosphere. If you cut a tree that is 50 years old and you burn it to heat your house, you're just releasing carbon in the atmosphere. If you cut this tree and you just transform it in a good insulation material, so you don't need to burn any fuel, anything to heat up your house, then this carbon is stored. It doesn't go back in the nature. It doesn't go back in the air. It's just stored, and then there's no release anymore of carbon. Slowly by slowly, we see on time. Of course, there's a release. The material needs to be processed, needs to be transformed, needs to be transported, but it's nothing compared to other materials, that any other material that is not natural, that is not grown, is directly emitting carbon. And why I'm speaking about this, about carbon and repeating carbon, and you can see low embodied carbon building and so on, it's just because the main problem we are facing today, as it has already been explained 2 times yesterday, but I'll just repeat once, is climate change due to human carbon emissions. So if we can store at least a part of the carbon, that will prevent some. And as architects, we can do a lot about it, because buildings are, and building construction, building usage is a large part of the emission of carbon in the world. But we can store this carbon in different parts of the building if we change our way of building. The structure can be out of timber. The insulation material can be out of natural fibers. The cladding materials can be out of other type of natural materials. The roofing materials also. There are a lot of solutions that were used before. That were used 100 years ago, 200 years ago, 5,000 years ago. Yes, now we are living in cities. We are living in a totally different world. We will not accept anymore to have only 5 or 7 degrees in our room during the winter, for sure. No one will accept it anymore. But building with those materials doesn't mean this anymore. We have other technologies that we can use. And that's why we need to make more research to be able to work with those materials better. But it already exists. They need more research, but people are already using those materials, and not only for small villas. And that's some of the examples I want to show. This is an office building, 3-level office building in UK, and in a university, made almost uniquely with local and natural material. Passive building, so very energy efficient. And that's it. And it is a hairy one. Yes, it is a hairy building that everywhere all around, but it has been elected as the best working environment in UK after its construction. So it's not only about construction, it's also about usage. People are happy to work in. So yes, hairy, but there is a reason for it. Heavy. Yes. Again, a 3-level office building out of walls that are ramped earth. So ramped earth is a technique of using earth, compressing it into a formwork. And this is a small building, actually, because it's a modern one, so it is only 3-story. Older building, same techniques, were built over 5 or 6 stories. Still standing, by the way. But there are building regulations nowadays that prevent it to be done, but it has been done. in Germany, in France, in countries where the technique is traditional. And there is no earthquake, of course. That's another. But this is something else. This can be done. But to make it done, the engineers working on the project, to make it accepted by the municipality and the regulating body, they just wrote 2 PhD theses on the topic. One on the heat resistance and how the building will be energy efficient enough according to regulation, and one about the Ramdas wall that you can see here, if it was strong enough to support all the weight. They are the load-bearing element. There is no other structure inside the building. So they needed 2 PhD theses, and that's what I'm telling. There is a need of research to go further. Weak, yes. Natural materials are weak. This material you can see here, it's called hempcrete. It's a mix between lime and hemp. You have on this model, I don't know, on this other side, but all around, you have such similar material, not with lime, with clay, or those samples here, the cylindrical samples, are the same type of material, but made with clay. You can touch it. That's really weak. Doesn't matter. It's not done to be strong. This is an insulation material. So an insulation material, whatever insulation material you take, modern ones, you take rock wool, you take EPS, XPS, or whatever, it is weak, most of them. Okay, there are some of them that are done to support some weight, but then you reduce their, you increase their thermal conductivity, they are stronger, they are denser. Yes, you can do the same with this. You put more clay or more lime, it's getting denser, and then it's stronger. Doesn't matter. The main advantage of this material, it doesn't burn. Second advantage, it breathes. And when we tell it breathes, it means that humidity, air humidity can go through. What does it mean? It means that if you use such kind of material properly, then you don't have rooms that are full of humidity, over humid, and then you don't feel comfortable inside because of the high amount of humidity. That's help for it. It's preventing some of the sick building syndrome by keeping the humidity as a normal level. But it's weak, yes. Dirty. Of course, those materials are dirty, like every other material, construction material. The main difference is we see it. Other ones, we don't see it. Most of the construction materials that are used are just coming ready on site. So it's not making dirt on the working site, okay? But those ones, yes, you take a straw bale and you move it. There's a lot of straw going around. I was doing my PhD in Matthieu in the civil engineering lab. And 3 years after I finished all my experiment, I came across one of the jury members that was working in this lab, and he was telling me, Matthieu, we are still finding some straw in our lab because of your experiment. Yeah, it's dirty, it's light, it's flying away, and it's visible. I was not complaining to have cement dust everywhere on my own experiment while I was working, but the cement dust is going everywhere around when you are doing it. But of course, you don't use the cement bag most of the time on site. Now the concrete is arriving directly ready. But if you had to prepare your own concrete on site and you open the bag and there's some wind and it's covered everywhere. People, when you pour concrete, the other day, my bike was out here and they were doing, I don't know what with concrete and so on. It was covered of dust. And what? It's not dirty. Yeah, it's not earth. It's not dirty. Earth is a dirty material. We are living out of earth. We are cultivating the plant. There's a lot of bacteria that are good for us, there it's dirty. Cement is a chemical, it's burning, it's killing everything, but it's not dirty. You need to think about it. How we face the fact, not what they are, but how we think about it, how we get used to think about it, because those materials that has been used during hundreds of years, thousands of years, has been forgotten since not a long time, actually. Not a long time, 70 years maximum, but they are everywhere. So what we do, or what do I do? How do I research? First, I don't do it alone. If you remember on the first slide, I can go back on the first slide fast. No, this is not. There is other logo. Yes, I'm at university. I am a university researcher, I'm an instructor, but I don't work alone. I'm working with an organization here in Turkey that is called Doğal Yapı Malzeme ve Yöntemleri Derneği, Association of Natural Building. And we are working together. There are other members of the association here. There is also another association I'm working with that is Matthieu Pedergnana, that I'm organizing workshop. I have been organizing workshops with a lot of other universities, never working alone. Anyway, it's not possible, not anymore. So that's what I want to tell. How we make it happen? By not working alone and working with students, since I'm at university. This is not my work. This is students' work. This was during the design festival last year. Yes, at the beginning, we introduced, I was again not alone, there were other instructors here, that some of them knew about those materials, some of them didn't, but it doesn't matter. We introduced the materials, we introduced the possibility, and how did we? By making students take those materials in their hand, get dirty, cut timber, mix mud and water and straw and understand. And then they were doing it. And they did it really good. You can see this model down in the exhibition of students' work. You can touch it, it's strong. Yeah, it cracked. Of course, this was not a research and final material. This was experimental to experiment possibilities. And that was really good. I will show you after a slide of something I have done, we have done during the summer, based on students' experiment during the design festival. Another thing they did during the design fest is this type of wall, rammed earth wall, blocks, and how to maintain it by designing some kind of post-tension structure. So you put the block on the top of each other, there is no mortar, there is no thing, and then you just compress it. And the students worked on it, they did it by themselves. They didn't invent it. There's nothing to invent. That's a technique that is already known. But they did, they design it in a way or another. And that's good to think about it. Or using different techniques to build. Earth doesn't have to be load-bearing. It can be used as insulation material, just as a cladding material. And there are techniques that are existing to build and even design a building, make a vault without any formwork. And it's a traditional technique that can be used, and that's done. And they just learned about it, retried it, and make it very well. There is no formwork to do this vault. Why I'm insisting on there is no formwork? Because formwork in construction is a high amount of waste, and timber waste most of the time. Especially special formwork that has giving special shape. If it's straight, you can reuse. If you have a special shape, you can't. And there are countries there is no timber. So techniques that prevent the usage of timber are already good to promote. This is front of you. I had a picture, but I thought that you could come and touch at the end. This model, again, is done with students, a group of students that came to me after the Kahramanmaraş earthquake and telling, Hocam, what can we do? And I had an idea, but then we developed it. We developed it together. Again, that was not my work. That was their work. And if it has been other students, it would be different. And if it has been another place that it would be built, this model, it would be different. The idea is just to use local material as an insulation material, local earth as a binding element between all those fibers, and covering with local earth plaster. It's a shelter. It's not something that is supposed to stay for 50 years. It's something that is supposed to stand for 1, 2, 3, 5 years, let's say. So there is no problem to use earthen material that are supposed to be weak and not water resistant. In the opposite, it is good to use those materials. After 5 years, let's put everything back to the ground. And then we have really good compost to transform the place where was a building into a field again, instead of having hundreds of square meters covered with concrete and then having steel bungalows, not comfortable because not insulated or not properly insulated, very small and not designed for large family. That's what we were working on. But be it with local material, because transporting these kind of materials on hundreds of kilometers, that doesn't work. Because using local material and local workmanship for people that just don't have a job anymore, that works better. So that's all about it. When you start to think about this type of materials, not only the materials by itself, which are natural, so good for the environment. But if you think about local, it means that the job, the production system is local too. You have to work with people living there. Nothing is produced hundreds of kilometers away. Everything is produced on the place, with the material on the place. And yes, we were aware that there were no more production facilities. There will most probably be a shortage of timber, shortage of tools, and so on. So the idea was to prefabricate the panels without the insulation material. So all the timber panels were ready, transported. And then the craftsmanship that didn't need experienced craftsman, not experienced worker, materials that can be found anywhere could be used directly. So this is thinking with biogenic material, natural material. It's not only about, instead of putting rock wool, I will put whatever hempcrete or insulation material I is proposing. No, the production system is changing too. It's getting more local. And that's how we can introduce it to students. That's from them doing this kind of experiments, they are starting to learn about all of it. And then we continue this work with the association and create a booklet to propose solution for reconstruction of affected areas by the earthquake or any other natural hazard by proposing different construction system. Not out of the blue. This is not new. There is nothing new. This is just trying to learn from what is existing, what has been tested somewhere else, adapt it to the local material, to the local craft, to the local knowledge. But for this, we need to test, to research, to find out the properties, especially if it is not to make a shelter that will last 5 years, but to make a building that will last 50 years or more. We need to make sure that those materials have good properties. And this starting back when I was working with my wife on a master's thesis project. So she had a research project on this light clay insulation. For 2012, 2013, we were working on it. And she produced hundreds of samples and she tested it for different properties. So here you can see some of the tests that has been done. She worked with pine needles because that was the local material easily available in ODTÜ. I don't know if you know ODTÜ in Ankara, but it is in the middle of a pine forest. So there are pine needles everywhere. So that was just testing how it works. And compared to materials that were already tested, the same material using straw, and the properties were totally similar. So therefore, it meant that pine needles could be used. And then I was working on my own research, but as soon as I could start again, now I'm coordinating a research project here at the university, again on the same type of material. And this, you see some of the samples we started to produce with students, but that's some of the samples you can see here. We use 8 different types of fibers to produce different panels that we will test for their insulation properties, their water resistance, their humidity transfer resistance, and so on, to see if they are appropriate for construction. That needs to be tested because there are so many parameters, and it takes a lot of research that we are very few in the world to work on. There is no lab here in Turkey working on. There is a lab on reinforced concrete in every other university. There is no lab in Turkey dealing with natural material at all. And we have to beg a spot in the middle of the concrete man to be able to work. And their machines are not adapted to those materials. And their production lines are not adapted to this material. So the research are not efficient. Because everything is turned into one direction, and we need to rethink how to do. This is my own research. I was working on earth plaster. This is one of the samples, we see the, I don't know, thousands of samples I created. And why I'm telling this? Because I started to research on plaster. That was not what I wanted to do as a PhD. As a PhD, I wanted to think about earthquake resistance of straw bale building. That was my first love, straw bale buildings. But the first thing I have seen is, yes, earthquake resistance is good, it's important. But if your building is not able to stand the first year because the plaster is falling down, then there is no point to have any earthquake resistance if the building is not durable at all. So then I said, okay, let's work on earth plaster and let's try to make it more durable. And how? Not by using cement or lime or any chemicals, because again, it's losing the main property of earth plaster, which is I grind it, I put it back into water, I can use it again indefinitely. And even some research has been done that if you reused old mud bricks, that you have one example like this, the new mud bricks you produce by reusing old mud bricks is even stronger than the previous one. So the fact of reusing and reusing, it's even better. So I started to work on it. So I did some mechanical resistance test, water resistance test, a lot of things with, you see the numbers here. These are the numbers of the sample. So you can imagine how much they were, how many combination I tried. This is the conclusion of my PhD. So I work on, but this is only the conclusion on the biopolymer additives that have been put in. There is nothing about the amount of fibers, the type of fibers, the amount of sand, the type of sand, and so on, the type of clay. It's just the biopolymers and the different type of test, showing that very good result. Whatever you do, you have no biopolymer that will, I mean, at least in the one that I have tested, that is a solution. It depends what you want to do with your plaster. If you want it to be more water resistant, or if you want it to have more strength, or if you want it to be more humidity, to have more humidity transfer and so on, it depends. So you need to know what you want to use it for. So, can we switch off the light, please? Şu kapatabilir miyiz? Teşekkür ederim. So then, yes, this is a research part. And I have shown at the beginning, it's good to introduce those materials to everyone, to experiment, to try, and then to apply it. So these are workshops, and really workshop with students, some architects, some people that wanted to build their own houses, and that are experiments too. So this state of the building is a straw bale load-bearing house of 20 square meter that has been built in 10 days. This is a state after 10 days, only by unexperienced workers, people, because they were not workers at all. They even didn't know how to cut a piece of timber, so most of them. But they did everything from the foundation to the roof in 10 days at the workshop. Straw bale was fast. We did the same with this type of material. It was a bit slower. But still, they did all the frame. So what I want to tell through this is we need testing. We did a lot of mistakes. But those mistakes were used to improve the techniques, to not make the mistake again, and to especially to introduce people to these different materials, how it works. And also that everyone could be educated to do this. If people that have no education at all into manual labor are able to do such kind of stuff, any worker in the building industry could shift its skill to make it much faster, much more efficient, and much more, how to tell, better quality. That was the state of these 3 small houses after one summer of workshop. By workshop with students, and of course, lot of volunteers coming to help. Unfortunately, our funding finished. So the third one that you can see here hidden has never been finished. Those are one have been finished and were used for people to live in. It was finished the year after. The third one has never been finished. That's how it is to work also with workshop and experiment. Doesn't always lead to what we want. Working with students, introducing them to different and alternative techniques. During 2 years, we have been doing workshop organized by ISTEC, the architecture department of ISTEC, and they were inviting students from all over Turkey to build with us. And a lot of different things were done and tested. This was to build an oven because they wanted to build a summer kitchen on the place. So we started with an oven out of earth. So different techniques. And then students made also rammed earth wall. What was important out of it is not this, or it's not the final part of the process, it's those two pictures. Students were doing all the work, meaning that we had a pile of earth at the beginning. It needed to be tested to find the right combination between earth and sand. So they tested it. It needed to be sieved and broken into dust so it can be used properly. They were doing it. And then they had to build a formwork, and then they had to build the wall. And students were doing it during the workshop, so they understood that a material, a finished wall, is not just about drawing it. There is a process behind, a process of building. And then, of course, I can tell you, I don't have a picture of the finished wall, but half of it collapsed at the end. No problem. That's part of the experiment. That's the reason why we are doing workshop. It doesn't have to be finished and perfect at the end. That's not the reason. The point is the process behind and learning from the mistake, learning from what was wrong. Other workshop, this time in Bergamo, in Bergamo. So over there, we just work on renovation of existing building. And then we applied same type of techniques. And again, students in architecture, staying for months and learning and building and making everything by themselves and introducing them into materials and new techniques that have never been tried here, at least in Turkey, to find out other solutions. So this making ceilings out of earth and fibers. Why? Because they were only, the ceiling was made only with a board. So to create some heat insulation, sound insulation in between, we needed to find a technique. So this was a technique available. This was a test. Again, it is testing, seeing what works, how to understand it. And as I said, I'm thanking the students that were working on the design festival last year, because thanks to their work, then during the workshop, we could do this one, using the same techniques of bending reeds, attaching them, and then filling with earth in between to create a vault. And why to do this? Just to test, just to see if it is working. Maybe next year it will not be here anymore because too much rain, because too much snow and too heavy, or whatever. Doesn't matter. No one is living in. No one is below there. If it collapses, it collapses. But the point is the process, trying to learn, trying to understand, trying to see how it can happen. This is not an engineering work. There is no engineering calculation behind. There is just testing and understanding. And this also can be done not only to test, but to create real scale building. Again, through workshop, again, with volunteer. And this is one house that has been done exactly using this type of technique, those materials that you are here, for the walls, for the roof, for the floor, as you can see here. But again, it's hairy, it's dirty. You can see this guy that is mixing, is covered with mud. Yeah, and what? It's better to be covered with mud than with cement. Cement burns, lime burns. Clay, just wash it out with water. Anyway, how many of you are just making some face mask with clay? I mean, that's used for beauty. So for aesthetic. So why not? Why it would be dirty? So this is the house, and this is what has been done at the end by unskilled workers, by students volunteering, learning, and making workshops. So this is not only testing. This is a house that is standing since, finished in 2019. So at least 6 years. People are really happy inside. So this is just a small introduction on what can be done with such type of material and what is needed and how we need to continue mixing education, research, applied work to make sure that people understand the necessity of it. So now I don't know if you have any question, but I'm ready to hear from you.
Sorry. All right. Thank you very much, Matthew. Is there any question from the audience? Henk.
Thank you. Let me break the ice then. I hope that there's going to be a lot of questions. Oops, it's just echoing very much. So I'm happy to stay. So it was really nice to listen to all those works that you and your team, your companions created in different geographies. My question might be a little bit challenging. I mean, you don't have to answer. Maybe I know it's not possible to answer, but I mean, what you propose here is giving real agency to the people, right? To the ones who need a house simply to inhabit in a place, and also giving agency to architects to really create what they design, what they envision in the first place. And this is clashing exactly really deeply with the purpose of capitalist economy, right? It means that if this plan works for everyone, we will not need any more, those big companies that you're talking about, for instance, making their money out of selling cement and also big construction firms. So I think the challenge here is, yes, of course, teaching people, like make them learn how to use those materials is important. But the biggest challenge, if you ask me, is to really, fight with the purposes, with the aims of those objectives of those big firms. At one point, probably you had somehow experienced same issues with them. So what would be the strategy? What would be the tactics to be able to win this war? Because it's a very, very difficult war. I mean, I know there is no easy answer, but I just need to hear your, thoughts on it.
No, it's totally true. In a way, there is this, but I'm really not afraid for the capitalistic system. They will go on, they will embrace it, and they will make money out of it. They already do. I mean, this hemcrete building here, for example, it is just, or all the example I've given, yes, it seems alternative here in this context in Turkey. But when you go to Europe, I mean, there are hundreds of examples like this that are built by big companies, big architects, and so on. Company like Lafarge or whatever, they already produce hemcrete blocks and sell hemcrete blocks. It's not a problem for them at all. They don't mind. They will just change their system.
So you think even in Turkey, those big companies can adapt themselves to this new way
If they
of doing
see
it?
that there's an opportunity, yes. And the opportunity, that's what I want to show. The opportunity is us to bring. If there is no one that knows how to do and no demand, they will not embrace it, and the scale will stay the small scale of the building I have shown at the end, what most of the architects and builders working on are doing right now. But if there are more people ready for it, more people showing that it may happen, unfortunately, I'm not afraid for the capitalistic system. It will always continue, at least until a point. So what is this is just a solution to not to change the system, but at least to put a bit of more appropriate materials, more localized work and job into the system.
But that sounds a good strategy then.
That's what that's what I think. Unfortunately, it's not what I want, but it's what will happen and is already happening. And it's maybe not for the worst. Maybe it's also a solution.
Okay, thank you. I have my answer.
Any other question? Yes, there.
Matthieu, thank you for the presentation. I have a couple of questions. Some of them I already asked you in person, but maybe it would be nice for the others to hear too. When I first heard about your studies, I was very anxious about the fire problem. I remember how it behaves with the fire, but you had some good responses. Maybe you can also share with people here about that. Plus, I would like to hear about the foundation of these kind of structures, mostly because in some of the images we have seen that you have some bags there, most probably full of stones or the ones that you have done. So maybe you can give us a couple of, pieces of information about that.
Yes, of course. Fire is not a problem.
Okay.
I mean,
I know you told me, but maybe it's good to tell me.
especially.
Tell me, give me one more question. What do you think about, for instance, having a skylight? Is it a kind of luxury for these kind of structures? Because it is the most critical point that we are generically having when we have these kind of openings. We will most probably have some problems in time with water. So with some other material, maybe I would feel more comfortable. What do you think about these combinations?
Yeah, you're right.
Okay.
When I'm saying fire is not a problem is because those materials have been tested. Yes, of course, if you try to burn those ones the fibrous one here right now in this state, they will burn. But if you just embed them between two layers of plaster, then first, there's no oxygen going in and out, so then there's no fire. And even if it starts to burn, it will char slowly, it will make no smoke, and it will not fall. And third, most of the time, they are not structural material. So there is no risk of having structural failure of the building. But that has been tested, of course, because some of those materials are used in public building, and there have been real testing of facades with straw bales or such kind of materials, and that's been accepted by the regulation until 2 hours fire resistance. So, and some real tests, crash tests, like in California, where there are a lot of wildfire and a lot of straw bale building, have shown that after the wildfire passed, straw bale building stays. Maybe there's no roof anymore because the roof is not resistant, but the walls are still here because they are covered with clay, with a material that is an insulation material, so it's not heating up anyway. So there stays, really. And I have demonstrated it once in front of the governor of Yozgat that was questioning this, and I just tried to burn the straw bale wall in front of him, and it didn't burn because it couldn't. But then he was happy of seeing that. That's demonstration is the best you can do. So yes, but humidity is totally a different question. And yes, we have to give luxury to people that suffer dramatic events. It's not a question of, it's maybe a luxury. Yes, it is. And we need to give it to them. I mean, you just lost your houses, lost members of your family, and then you are locked in a 2 meter 30 height, dark bungalow. I mean, how can you recover? How can you recover? Give the luxury to people to come back to their life. So yes, there might be problems, I say. But this problem is not because of a material. This problem is a craftsmanship. And then if there is good craftsmanship of skylights, then there's no problem. And yes, humidity might be a problem if there is humidity in such materials. But at the same time, if the layers of the roof or wall are taught properly, as I said, they're breathing material. They will dry. If they can dry, then humidity won't be a problem. If they stay humid, that will be a problem. Or maybe we can think that we need to put some fungus inside, the good one, so there will be mycelium insulation instead of those materials. Mycelium is a new material that has been developed more and more as a construction material. So maybe growing the right fungus, telling that if there is humidity, then the right fungus will grow, and then we will have mycelium insulation that will be even better. I don't know, we need to think about that. Foundation is just foundation. If you have a light building, then you can have light foundation. If you have a heavy building, if you don't change the construction technique, and you have a reinforced concrete structure, and then you just use such material as infill wall and so on, then the foundation will stay the same foundation, maybe a bit lighter or not. That's exactly the next project I want to work on, is to see what might change using those type of material into the structure itself of buildings. But foundation are here, yes. And that's another reason why we never lose the concrete industry. Concrete, reinforced concrete is still a really good material for foundation. Yes.
Thank you, Matthieu. So I will try to continue from the concept of actually industrialization. I think the first question was about that, industrialization of this, I will say, emerging materials, but they are not actually new materials. So have you considered like working on panels instead of blocks? Like you mentioned with the plaster panels, we did some work in Belgium using wood fiber panels. So it's actually the same concept. But do you think prefabrication would work with this? Together with, I think, self-building in Turkey should be remembered and retaught in our country, that's for sure. But we also need big companies to prefabricate. Do you think that would work for your studies, for example?
100% sure.
Yeah. And I will ask another question to everyone, because what we did in Ghent was to build up a circular bio-based building and ask to locals about if they really like to live in such a building. And then I would like to ask the students if they would prefer staying in this house that you see now in front of Matthieu, or would you prefer the regular ones?
You're not talking about size, right?
I'm not.
This one is an apartment building in the center of Paris.
Yeah. But then do you think prefabrication would work?
Yes, it is.
Are you working on it as a...
No, right now I am not. I'm
Okay.
working on the material side yet. But prefabrication is not much more complicated.
Yeah.
It's just, I mean, not this one, but some of them are the same. There's a Hemcrete 9-story building in Paris again that is made with prefabricated facade panels. So they are coming directly ready and placed on the structure. So it is already done, whatever type of material. This is prefabrication too. These are reinforced Raptors block, prefabricated somewhere, moved on site.
Thank you. I feel like now I'm going to get the flag and revolutionize. Now I said it against the construction industry. Yeah, but it feels like that, and I think it's not about only developing ideas for industrialization or multiplying or developing a huge building. I think it's about life. Um, it's about needing less, producing less, consuming less.
Definitely.
So I think we don't need to improve that idea for mass production, because if you need to live, if you want to live with the less, if you want to make it for yourself or for your neighbors or people just for good, then it's a really good way. By the way, cement industries all the way, you know, they for 10 years they are trying to replace cement with other materials with fly ash and other ad binding materials. So capitalism is on the way and they're really far away. So they're going to find a way to survive for sure. The lesson I have from this amazing sharing of the ideas, I need to find a way to limit or decrease the needs, my expectations, my ambitions. Otherwise, it will be really difficult to survive. So we need to consider that. We need to find a way to produce less, to consume less, to need less. Thank you for that. It's really important to remember and to put it in the pocket. Thank you.
I agree on it, but whatever less we will need, there's still 8 billion people actually on the planet, and they need houses. They are kids, half of them are kids, but it means that in 20 years they will need their own building. So we will need more building. We have to build more buildings. So building less, yes, but cities will still increase. But we need to find solution for the cities to embrace these type of materials that are much more sustainable, much better for the environment and for the people than the one we are using nowadays.
Yeah, that's right. I like to underline one more sentence. You mentioned, you said we need to create work possibilities and
Yeah.
we need to find a way to develop on-site job possibilities, opportunities. Otherwise, you know, when yes, it's possible to develop some techniques and methods to for mass production of this kind of houses. But if we cannot provide job, they will move to the city center to have concrete block houses. So it's better to help to develop on site in their own places. That's the key, actually.
Our city center will made with such type of building. This is city center of Lyon.
Other parts of the continents and the world, it's really difficult to. You have already
What?
the tradition.
So then, but the tradition is just 10 years. It's 10 years that is developing in France, this kind of material. But it's based on the 30 years ecological activism that try to push and make small stuff. And now, by law, there is a need of using biogenic material. You have to. But that's the reason why I'm telling you, everywhere it will evolve and we don't have any other choice. And we need to embrace it right now by educating the new architects on it.
May I add a question to that?
Yeah.
Thank you for your presentation, Matthieu. I'm also not concerned about the industry. I think they will always, like money always follows demand. But I think in future it will also follow availability. So you're also talking to a certain extent, I think at least, the availability of material, like local material, using local material on site, which comes from the site and stays on the site. So shortening or cutting transportation and all these kind of, which has huge impact on CO2 emission also. What I want to ask as a question is, probably you're familiar with Jonah Friedman's work, which he published for the UN, Building for the Poor, I think was the publication, books. I think in the 1970s, 80s, probably.
I don't remember, but
yeah. Unfortunately, he died recently, right? The question for me is, do you work on something like a guideline, a manual for people who are, as you always mention, unskilled, to be able to follow these advices and follow strategies for making this technology or technique their own, or remembering this technique, or how you teach the students this technique, but how to proceed from there? What is kind of like, because architecture usually is aiming for development and proceeding to some further goals. So what are your thoughts on that?
Right now, I haven't worked on guidelines and so on. I'm not enough a professional on it to be able by myself or even with the friends here to write those guidelines. But for example, last year, again, with the association, we have been working with a teacher in a vocational school and teaching them about those materials and introducing them to those materials and techniques so they can introduce it to their own students that are the ones that will be at a point using those materials on site or being working in the municipalities or companies. So actually we are trying to spread information and knowledge about it. But yes, you're right. There is a need of guidelines, guidebooks, manuals for people to do it. But I really believe that more than this, it's just a need of going into vocational school and making workshop with the people. I had been working on a workshop with a municipality. And so there were all these students on the workshop, and there were 3 municipality workers helping us. They never had touched such material, but they knew how to, they were builders. They were ustas, as we say in Turkey. So they observed, and then they told me, okay. And they took the material, and what I was doing, the students were doing in 2 hours, what I was able to do in 30 minutes, they were doing in 10 minutes. Because the skills they already had, they just transferred to these materials that are not really different in general. Not all, but most of them. It's once you know your job, you just transfer the skill into a different type of material, but you can transfer. So I'm not really afraid for the workers to be able to use them once they know about it, once there is a demand. What is more complicated is us, engineers, architects, designers, to embrace what changes need to be done for using those materials. As I said, it's not only changing one material to another. The construction system is different. The idea behind it is different. The way of using the building might be even different. So that's about it. And yes, Jonah Friedman was already, and what I'm telling, what is happening in Europe is because of all these years of ecological activism, social activism, trying to start with it. And now, I mean, I'm taking France as an example because I'm French, but in Austria, in Germany, in Denmark, in UK, that's exactly the same. In the United States also, they are working a lot with it. They were the first one to come out with a national regulation on load-bearing construction with straw bales, and that are accepted everywhere in the United States, not only in California where it started, but everywhere in the United States, even in earthquake area and so on. They've made all the tests. They worked a lot on it. So everything is based on such kind of stuff. So yes, guideline is really important, but I'm more concerned by us than by the workers that they will find out.
I learned you're a fearless person, obviously. But what is the difference then? Where is apprenticeship ending and academia starting, and what can academia add to that?
No idea. I mean, at least for me, no, on my side, no idea. I mix everything all the time. That's what I'm thinking. For me, there is no.
I think this is a very good topic for the coffee break. Now, out of joke, I would like to thank Matthieu for his fantastic presentation. So please, a big applause for Matthieu. Thank you very much. And we're going to have a coffee break, 15 minutes, and then we continue with the conference. Thank you very much, everyone.